Most research on diet and brain health deals in associations and long-term population trends. This new study is different. It provides something more specific, a measurable quantity of brain aging reduction linked to adherence to a particular dietary pattern, tracked over 12 years with MRI brain scans in over 1,600 adults. The diet is called the MIND diet. The study was published in the Journal of Neurology, Neurosurgery and Psychiatry in March 2026. The finding is that people who more closely followed the MIND diet showed brain structures that were measurably younger than those of people who followed it less closely, with the most adherent participants showing brains that appeared 2.5 years younger in key measures of brain tissue health. Here's what the MIND diet is, what the study actually found, and what the specific foods are that drove the most significant effects. The MIND diet was designed by researchers at Rush University specifically to combine the most brain-protective elements of two well-established dietary patterns. The Mediterranean diet, which emphasizes olive oil, fish, vegetables, legumes, whole grains, and moderate wine, and the DASH diet, which is the Dietary Approaches to Stop Hypertension protocol, emphasizing low sodium, high potassium, and fruits and vegetables. Both diets have strong evidence bases for cardiovascular and cognitive health independently. The MIND diet takes the components of each that have the strongest associations with brain health and organizes them into a specific framework. The MIND diet emphasizes 10 food groups: green leafy vegetables, other vegetables, berries, nuts, olive oil, whole grains, fish, poultry, beans, and wine in moderation. It limits 5 food groups associated with cognitive decline: red meat, butter and margarine, cheese, pastries and sweets, and fried or fast food. The limitation of saturated fat sources is central to the MIND framework, as saturated fat is associated with increased inflammation and vascular risk factors that affect brain health. The study followed over 1,600 adults participating in an offshoot of the Framingham Heart Study, a long-running cardiovascular research cohort. Participants enrolled with an average age of 60, with no evidence of stroke or dementia. Over an average of 12 years, they completed dietary questionnaires, underwent regular health checkups, and received at least 2 MRI brain scans. The MRI data allowed researchers to directly measure changes in brain structure over time, including gray matter volume and ventricular size. Gray matter is the brain tissue that contains the nerve cell bodies responsible for memory, cognition, decision-making, and sensory processing. As the brain ages, gray matter volume naturally decreases. Slower gray matter decline means the brain is maintaining more of its functional tissue for longer. The study found that for every 3-point increase in adherence to the MIND diet, there was 20% less gray matter shrinkage, corresponding to a 2.5-year delay in brain aging on this measure. Ventricles are the fluid-filled spaces in the brain. As brain tissue shrinks with age, the ventricles expand to fill the space. Ventricular enlargement accelerates after age 60 and is one of the structural markers associated with Alzheimer's disease and cognitive decline. The study found that for every 3-point increase in MIND diet adherence, ventricle enlargement declined by 8%, corresponding to approximately 1 year of slower brain aging on this measure. These are not marginal findings. Slowing the structural aging of the brain by multiple years through dietary choices, tracked over a decade with imaging evidence, is a clinically meaningful result. When the researchers looked at which specific foods within the MIND diet contributed most to these protective effects, 2 stood out. Berries were associated with slower ventricular expansion. Poultry consumption was associated with both slower gray matter decline and slower ventricular enlargement. The researchers attribute the berry effect to their high concentration of antioxidants and other bioactive compounds that reduce oxidative stress in brain tissue. Berries, particularly blueberries and strawberries, have been among the most studied foods for cognitive aging specifically, with mechanisms involving flavonoids that cross the blood-brain barrier and reduce neuroinflammation. The poultry finding points to the role of high-quality lean protein in supporting brain structure maintenance. The brain requires substantial protein for neurotransmitter synthesis, myelin maintenance, and structural support. Lean poultry provides this without the saturated fat load of red meat, that is associated with the vascular risk factors and inflammation that accelerate brain aging. The researchers also identified foods that accelerated brain aging. Sweets and fried fast foods were associated with faster ventricular expansion. Eating more sweets specifically was associated with faster hippocampal decline. The hippocampus is the brain structure most centrally involved in memory formation and is typically one of the first areas affected in Alzheimer's disease. The association between sugar and refined carbohydrate intake and hippocampal atrophy is consistent with earlier research showing that blood sugar dysregulation damages hippocampal tissue through multiple mechanisms, including inflammation and advanced glycation end products. Two findings in the study deserve a careful interpretation note. Cheese consumption appeared to be protective in the analysis, and higher whole grain intake was associated with faster gray matter decline. The researchers caution against reading too much into either result. Cheese is heavily limited on the MIND diet, and the protective signal is too small and context-dependent to be interpreted as a reason to eat more of it. The whole grain finding likely reflects the composition of whole grain foods available and consumed in the 1990s when the study began, which may have differed significantly from what would now be classified as a truly healthy whole grain food. The primary takeaway from the lead researchers is the same point that nutrition science consistently makes. What matters most is the overall dietary pattern, not any individual food in isolation. Foods are consumed together, and their combined effects are more important than any single component. The MIND diet, followed consistently over years, produced measurable structural protection of brain tissue in this study. The Mediterranean and DASH diets have separately demonstrated similar patterns in prior research. The commonalities across all three patterns, which include abundant vegetables, especially leafy greens, berries, fish, lean protein, nuts, olive oil, legumes, and whole grains, combined with minimal saturated fat, fried food, and added sugar, represent the most consistently evidence-supported dietary approach for brain aging available. New videos every day covering the nutrition and health science that matters for how well you age. Subscribe and stay with us. The study's design is worth understanding because it strengthens the confidence that can be placed in the findings. The use of MRI brain scans at multiple points over 12 years gives this research something that most dietary studies lack: direct objective measurement of the outcome of interest rather than reliance on cognitive tests or self-reported symptoms. Brain structure does not lie. Watching gray matter volume and ventricular size change across a decade in over 1,600 people, while simultaneously tracking what those people ate, provides a much more direct link between dietary pattern and brain aging than most prior research in this area has been able to establish. The observational design means it cannot establish causation with certainty. People who eat well may also have other health behaviors that protect brain health, and separating the dietary effect from those confounders is inherently difficult. The researchers acknowledge this limitation, and a specialist in preventive medicine consulted in the coverage of this study noted that reverse causality, where healthier brain function produces better dietary choices rather than the other way around, cannot be fully excluded. But as that same expert noted, the more obvious causal pathway, that eating well protects brain structure and function, is the more biologically plausible direction. The mechanisms through which anti-inflammatory, antioxidant-rich diets protect neurons are well established at the cellular level. The population-level evidence across multiple cohort studies points consistently in the same direction. And the 12-year time frame with structural imaging makes this particular study more persuasive than a shorter or more subjective measure would be. The practical implication is what it always is with the strongest dietary research. The evidence for eating a diet that emphasizes vegetables, berries, fish, lean protein, nuts, and olive oil while limiting saturated fat, sweets, and fried food is now strong enough across enough outcomes, including cardiovascular health, metabolic health, and now measurable brain structure, to treat it as a genuinely important long-term investment.